Okay, for the next type of equation, or the next few equations, we're going to depend on some of the methods we've learned up until this point. And we're definitely still going to use the trig ideas, but we're going to also incorporate other ideas from math as well. So, for example, let's say that our function is secant of theta plus the square root of 2 times 2 cosine of theta plus 1 equals 0, and I'm looking for theta such that it's between 0 and 2 pi. So on this one, it's already factored. And that's fantastic, because remember when we were finding the zeros of functions, we talked about how you can set each factor equal to 0 and solve them separately as two different equations. So here I have that secant of theta plus the square root of 2 equals 0, and that 2 cosine of theta plus 1 is equal to 0. And you'll solve each of them, minus, like an ogre. Let's see, minus 1. And remember, your secant is the same thing as 1 divided by cosine. And so if I wanted to solve this for cosine, I can cross multiply. And I get 1 equals negative square root of 2 times the cosine of theta, divide by negative square root of 2. And that negative can stay on the bottom, but really I think it's better to put it on the top. Just so long as you only have it once, it doesn't really matter. You can also put it out in front. And we find that our cosine of theta equals negative 1 over the square root of 2, or cosine of theta equals 1/2. So over here on the unit circle, I'm going to find all the places where that's true. So I'm going to start with this one first. So my x value is negative 1/2. I can see that happens here and here. And then for my cosine theta equals 1 over the square root of 2. Now granted, they have it rationalized, so that they have 2 divided, or well, on top you have negative 1 times the square root of 2. On the bottom, negative 2 square roots of 2 squared. They cancel the square root and the squared. So just so that I'm in the same format as this unit circle, and I can see that I've got that right there and right there. So I know for this problem, inside the unit circle, the angles 2 pi over 3, 3 pi over 4, 5 pi over 4, and 4 pi over 3 all will satisfy my original equation. Okay, let's try another type of equation. So we're going to find all the solutions to this equation here. And again, you just don't have one trig function here, so I would solve it like an ogre. So move that. And I know we haven't played with cosecants much, but for now, you don't need to worry about that. Not for another step. Okay, now when you take a square root of a fraction, remember you can take the square root of the top and the square root of the bottom separately. The square root of the top simplifies, but here the square root of the bottom does not. Okay, now I taught you, what was it, last class I think, or the class before, I can't remember right now, that cosecant is the same thing as 1 over sine. Now here's a trick I didn't do in the last problem. Very conveniently, that act of cross multiplying and then dividing is just going to flip both of these upside down. This is okay to do only if you have fraction equals fraction. That we're going to get sine of x over 1 is equal to square root of 3 over 2. So I come over to my unit circle, and sine, remember, goes with the y values, cosine with the x, and my sine will equal square root of 3 over 2 here and here. So my x value would have to be equal to pi over 3 and 2 pi over 3. Okay. I'm basically going through at least one of each type of problem on your homework. So if you haven't started that yet, you'll see here in a minute. Next problem that I want to do looks like this. And again, I'm going to solve for what's on the unit circle. Now on this one, I cannot solve it like an ogre because we have the function show up twice. So you're going to have to think about this as if it was 2, I'm going to say a squared minus a minus 1. When you see things like that, you have some choices. You can try to factor. You can use the quadratic formula. You can complete the square. I'm going to try it with factoring and see what happens. Okay, so I'm going to use the box and diamond method. I'm going to place the first term, and I'm going to go ahead and keep the a's here because I do think that will help you guys a little. That whole act of putting signs in just puts enough letters into the situation. It does feel a little more confusing. And if you want to, you can even make this an x. Like, honestly, it doesn't matter. Maybe I'll go ahead and make it an x, because that's what you guys are most familiar with. Alright, and then you multiply the first and last thing together. You put the middle thing here. Alright, so this is pretty easy. All that we could use is 2 and 1. X and x, and if I add them together to make a negative x, it means this one had to be negative, right? You can double check me on this. So this here and this here, I can see that this would factor out. And that. And that. Okay, but remember, x is not really x. X is the sine of x. So what we have here now is our 2 sine squared of x minus sine of x minus 1 is going to be the same thing as 2x plus 1. Oops, there I go, putting x just as soon as I said it's not. 2 sine of x plus 1 times sine of x minus 1. And now I've got it in factored form. I can set each thing equal to 0 and solve like I did in the last problem. And once you've got these solved, now it's time to go to our unit circle. So sine is your y, We want something on the bottom half in the negative y values. So I see that I have a negative 1/2 here and here, and that takes care of that first one. For the second one, I have sine of x equals 1, so your y value equals 1. That only happens here. So in this case, my x values that would make this equation true, the only ones that will work will be pi over 2, 7 pi over 6, and 11 pi over 6. Okay, so one last problem. And again, if you have questions on any of these, please do let me know. But I am going to make it this last problem. I want to test you a little bit with the Pythagorean identities. So in this problem, I've got an issue. I've got a sine and a cosine. That's really not a feasible thing to solve right now using any of the methods that we've taught you. But, especially because this one is squared, I actually can change it to something that involves sines based on the Pythagorean identity that I taught you at the beginning of the week. And what I taught you was that if you take a sine squared of an angle plus a cosine squared of an angle, it equals 1. And you can go back and watch the lesson from 2 class periods ago to see the proof on why that's true. It's true for any angle you put in for theta. And you can test it. You can pick any angle that you want, square the sine, square the cosine, add them together, you'll always get 1. Okay, so I have a cosine in this problem, so I'm going to solve this for cosine, which means I need to move the sine squared. Oh, I knew I was getting close to that. Okay, that goes away, and I get cosine squared is the same thing as 1 minus sine squared theta. So, on my problem, I'm going to substitute that in. I have 5 sine x equals negative 2 parentheses. Let's move that because I am running out of room. I naively thought maybe I could make it work. Two times, now cosine squared theta equals 1 minus sine squared theta, and then plus 4. So only the cosine squared got pulled out, and we substituted in what that equals. It is very, very important that you put it in some sort of parentheses because this 2 will get distributed. So now you're going to treat it like you would if it was just x's here again. Speaking of, I have both thetas and x's in the problem. Not a great idea on my part. I'm going to combine like terms here. 2 sine squared theta plus 2. And then because I have, again, something to the first power and something squared, you want to be able to factor it or use the quadratic formula. You're going to have to put all of your terms on the same side. Your function has to be set equal to 0 to make this work. It's really easy to multiply together things and make it equal 0. It's really hard to add randomness together, especially with variables on both sides, and make them equal each other. Alright, so let's try it with the box and diamond again. I'm going to make that a little bit bigger though, because this time I am going to put the signs in there. So I have 2 sine squared x 2. I'm going to have 4 sine squared x and 5 sine of x. Now there's only really 2 ways to multiply together and make 4. And conveniently, one of them does add up to give me 5 here. So I put those in the box. And I factor out what I can. Oops, not squared. Yep, that looks like that will work. Okay, so I now have that my equation is the same thing as 2 sine of x plus 1 times sine of x plus 2. I'm going to set each of them equal to 0 and solve it like an ogre. Alright, and once you're to this point, then we're going to come over to the unit circle. I have sine of x equals negative 1/2. Remember that was the y. So I see that here my theta equals 7 pi over 6 and 11 pi over 6. And here I've got something interesting going on. Here it tells me that sine of x is equal to negative 2. And as you go around the unit circle, you can see that there is no place where your y value was equal to negative 2. And if you think back to your graphing of sine functions, remember it maxed out at 1 and its minimum was at negative 1. So in other words, down at negative 2, the function does not exist. So this one here just won't give us a value that would make my original function equal to 0. There's just no angle from that second equation that would set that equal to 0. Turns out it's only this first factor that can affect the function in that way. Okay, so this is your very, very last homework of the year. After this, I am going to be assigning your final, which will be the same as your midterm, except for trig identities and such. If you have any questions, let me know. It's been really a fun year working with all of you, and I'm grateful that we were able to spend 3/4 of the year, roughly, almost, all working together in the classroom. And I know I'll get to work with some of you in the future as well. So let me know if there's anything I can do to help. If you have any assignments that you have not completed, just let me know and I'll open them back up again. You'll have until at least until May 22nd, but realistically I know that we're going to work with you even past that, but I don't know how it's going to work after May 22nd, and I know you're not going to have full access to me after that because of the summer months. So, and I definitely don't recommend that you try to put it off past summer. So really, if you have anything that you're missing that you want to make up, make sure that that's getting done before graduation. Okay, I'll talk to you all later. See ya.